Hello and welcome to Maths with Mr Amison. In this video I'm going to present some practice questions on how to calculate interior angles. If you need to recap this topic, then please watch this video here or follow the link in the description below. I'm going to start off by going through a worked example. I'm going to show you the working out, then go through it in detail. Feel free to pause and follow along. So I started this question by recognizing that this is a five-sided shape. It's got 5 angles, therefore we can do 5 minus 2, then multiply that by 180 to find the number of degrees inside the shape in total. Or we could draw triangles in the shape, see how many triangles there are in the shape. And seeing as each triangle will have 180 degrees, that would give us the total number of degrees in the shape. This is in fact a pentagon and therefore has 540 degrees. I then recognised that this 130 degrees was not inside the pentagon. We needed to find the angle Y. Now in order to do that, I recognise that this here makes a straight line, therefore that these two angles add up to 180. So 130 plus Y is equal to 180. If I subtract 130 from both sides of the equation, I end up with Y equals 50. Now adding up all of the angles inside this pentagon, I should end up with 540, which is represented here. So in total, 377 plus X would equal 540. If I subtract 377 from both sides of our equation now, then we end up with X is 163. Your turn. Have a go at finding the value of X. Pause now. Now you've had a chance to have a go, let's go through it. So here we have this angle that we're trying to find, because we need all of the interior angles of this shape to figure out this one. So we need that one to be included. And I also recognise that we have 6 angles inside this shape, 6 sides, therefore it's a hexagon, and we can calculate the total number of degrees inside the hexagon is 720. I also recognise that the Y and the 60 are around a point, therefore they add up to 360. If I then subtract 60 from both sides of our equation, we end up with Y is equal to 300. If I then add together all the angles inside the hexagon as so, I end up with 720. If I collect the like terms, simplify a bit, I have 615 plus X is equal to 720. And then if I subtract 615 from both sides of our equation, then we end up with X is equal to 105 degrees. So another worked example for you. I'm going to show you the working out and then go through it afterwards. Feel free to pause at any time, try and follow along. Okay, the first thing I did is recognise that 1260 divided by 180 will tell us how many triangles we can make inside this shape, as every triangle has 180 degrees. And then it's useful to recognise that the number of triangles you can make inside the shape is always 2 less than the number of sides that shape has. Therefore, 7 add 2 gives us 9 sides. Then, because we have 1260 degrees altogether, the size of each angle, if we have 9 sides, that means we have 9 angles, so 1260 divided by 9 will give us the size of each angle being 140 degrees. Your turn. Pause now to have a go at the question on the right. So in this question, a regular polygon has 11 sides. If it has 11 sides, that means we have 180 multiplied by 2 less than 11 to give us the sum of the interior angles. Therefore 180 multiplied by 9, 1620 degrees. What is the size of each angle? In this case, if we have 1620 degrees and it's a regular polygon, that means every angle is the same size. 1620 divided by 11 will give us the size of each angle, which is 147 degrees to 3 significant figures. So here are 6 questions to have a go at based on those 2 example pair problems. The green ones are the easier ones, the orange one is a little bit trickier, and the red questions really are quite difficult. It's worth pointing out that this is a regular shape, and both of these are also regular shapes. Pause now to have a go. The answers to those questions: for the first one, x is equal to 90, as this angle up here is equal to 60, and there's 360 degrees inside this quadrilateral. This is a regular octagon, therefore x is equal to 135, because we have 6 lots of 180 to get the total number of degrees inside the shape. Divide that by 8 to get us 135 degrees. For question 3, a regular decagon. A decagon has 10 sides. 180 multiplied by 8 then gives us the total of the interior angles, which is 1440. Divide that by 10, because there are 10 angles, to get us 144 degrees. For question 4, we have parallel lines in our shape. Because we have parallel lines, it's worth noting that this angle here and the angle in the bottom right will add up to 180 degrees. Therefore, the missing angle here is 100. The missing angle here, because these angles add up to 360 around the point, is 260. So if we add these all together, because we have a 5-sided shape, that's 3 lots of 180, which is 540 degrees inside the pentagon. If we then write the equation out and solve it, we get x is equal to 60 degrees. Question 5 is really quite tricky, but you have to recognize that this 4x and this n are corresponding angles. Therefore, n is equal to 4x, which means that this angle here is 8x and this angle here is 4x. It also makes it easier to recognize that because this angle and this angle are co-interior, they add up to 180. So because we have 540 degrees in the shape in total, we can do 8x plus this angle here, which is 240, plus 4x plus 180 will give us 540 degrees. If we solve that equation, then we end up with x is equal to 10 degrees. For question 6, we have an equilateral triangle and a pentagon, a regular pentagon. Each angle in the equilateral triangle is 60 degrees. Each angle in the regular pentagon is 108 degrees. Therefore, the missing angle here would have to be 192 degrees, because the angles around that point would add up to 360 degrees. If we then solve this equation by subtracting 38 from both sides and dividing the answer by 7, we end up with x is equal to 22 degrees. Thanks for watching. I hope you found this useful. Speak to you soon.